SoftClinic PV plant, a Weidmüller program for data collection and management of a solar power plant. This tutorial video will explain the steps for the correct configuration of this software. There are three parts in this setup procedure: the editor, the runtime, and the monitor. The editor will be used to configure all of the instruments installed in the solar plant and will also collect the data which has been generated. Runtime is the software which collects all the parameters that have been configured in the editor. This software is the link which connects the database and the solar plant. The monitor shows us the plant data in real time, as well as all of its historical data. The monitor also provides us with a graph where we can follow the progress of the plant. We will now configure a plant using the Site Manager. The necessary parameters to do so are Site Manager and New Site. Here we will enter the location or the name of the plant. A short description will help us to remember where it is situated. In the server host, we need to tell the program where we want to store the information to be collected. It can be a local or an external IP, and if it is the computer in which we will execute the runtime and monitor, we will call it local host. The name of the database is important because this is where we will find all our data. Here we have entered Zona Norte. Username and password corresponding to what was entered in the database. We do a connection test. Test connected OK? And we connect. Thus, we have created our park. And now we can check the information previously entered. Barcelona, Zona Norte, localhost. Now we will enter the time intervals for the online and the historic updates, and also the size of the historic database. The historic size can be a year or a month. Here we select RMS values and the voltage at which historic recording will start. Now in communication, we will configure bus communication through which we receive information from the plant. Communication, new, communication device. Let's put in a bus name, bus number 1, and then a short description to help us remember its location or origin. Here we have options for data transmission. TCP/IP 232.422 if it is COM1, baud rate, stop bits, bits, number of bits, parity. In the case of communication via Ethernet, we enter the port and the IP address. New device. Different communication buses can be used, and we will now configure another one. We have two of them, bus 1 and bus 2. We move on to users. We can create users individually or in groups. Let's create a group. As we can see, the user is Enable. Now we'll create a group of administrators. We create a user and a name. We enter the username, enable, put in the password. It's essential here to confirm the password to guarantee correct access. Password, check. In host, the percentage entered is important for the system. because it indicates that the user has access to the data from an external source outside the network of the park. We then enter the full name of our user. We add a brief description. We will now configure an email. This is a method which will be used to alert us to any incidences which may arise in the park. First, we enter our server name, and then our user ID and our password. Then we enter the address which we are sending our email from. In organization, we enter the department from which the email is sent, and then in subject, who has sent it. SMS groups is another troubleshooting tool for the plant. First, we need to configure the SMS modem. Here is where we enter the program where this modem is connected, as well as the mode. 232, COM1, COM5. Logically, we cannot repeat the COM port. SMS groups is where all the messages of the plant will originate. We create a new group, and then we create the message, the name, and then the message text. Warning 1. We enter the telephone number we are sending the message to. In custom devices, we configure the communication devices connected to our system, which have been made by a company other than Weidmüller. We can also create the configuration and parametering of variables. We now create a custom group, whose name will be Group 1. We can enter a brief description. We will insert a device into the group, in this case, inverter. In this table, we enter the communication address, or we go to our pre-configured libraries. Counters, inverters, meteorology station. Here, inverter. Here, we configure the bus where it is connected, the station number of the bus, enable historic of the registered data, and enable alarms. Type, address, name, and description. This information has already been entered into our library. Even so, we can modify it at will. Data name, description. In string boxes, we will now configure our system. We select a group, give it a name, Area 1, and add the type device installed. We give the module a name. We indicate the bus it is connected to, the station number, enable module, enable alarms, the voltage conversion factor being red, In alarms, we find a large selection of alarms by deviation, maximum and minimum currents, temperatures. Here are the values at which the alarm goes off and the delay seconds between alarms. Our plant has now been completely configured, and we can see that all elements have been correctly set up. We close, accept changes, and we return to the main screen of the editor, where we see that the configuration has been correctly recorded in our system's database.